Okay, students, class 10. Okay, let us start today a very interesting topic of application of refraction of light ray, and that is critical angle and total internal reflection of light. So actually that is also the extension of refraction of light ray. We should know what is critical angle, how it gives the effect of total internal reflection, and we can understand this critical angle on the basis of our idea of refraction of light, and then we can explain many of the phenomena around us, like mirage, like why the road in the highway in the summer days looks wet, or it looks that there is a water thrown there, but when we move there is no water. Actually, these are all the application of total internal reflection of light. Why diamond glitters? Why diamond glitters? What is the reason of glittering of diamond? That could be explained also on the basis of total internal reflection of light. But we should understand first critical angle on the basis of our concept of refraction. Okay, students, so we are talking these days refraction of light ray, and it is very good to go deeper in this topic so that we can understand more details. This refraction always involves two mediums. That is very important. Refraction always involves two mediums, one rarer, other denser. Any two medium could be there. It could be air and glass, it could be air and water, it could be water and glass, any two medium. It could be vacuum and water. So how this refraction of light could explain critical angle. So what is critical angle? Let us try to understand this. Very important term, critical angle. Okay, students, class 10. All of you watching this video, try to understand critical angle. So, before defining critical angle, let us understand with the help of diagram. Now see, this is a refracting surface which separates two media, maybe one denser and another rarer. So what we know, actually we know that when light rays move from denser to rarer, then it bend away from normal. This is normal, and the light ray will bend away from normal. So this is incident ray and this is refracted ray. So what happens? Because light ray is moving from denser to rarer. So this is very much clear here when we are talking that this is angle I and this is angle R. Now if we will increase angle of incidence, then what will happen? Okay, what will happen when we increase angle of incidence? Maybe from I1 to I2. Then angle of refraction will also correspondingly increase. It will also become from R1 to R2. So if we are increasing more angle of incidence, one time will come then the corresponding way angle of refraction will be 90 degrees. Okay. One time will come for a particular angle of incidence. Okay, when we call it particular angle of incidence, maybe for which, maybe this is the particular angle of incidence I3, for which the angle of refraction will be 90 degree, or we can say the light ray will move after refraction along the surface like this. So corresponding to this third incident light ray, refracted third light ray is along the normal, along the surface. Okay, along the surface. And here angle of refraction is 90 degree. Then this angle of incidence is called critical angle. Okay, so now we can define critical angle. Critical angle is that angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degree. Okay students, this is very important topic, and this will give you more deeper understanding of refraction of light ray. This will give you more deeper understanding of refraction of light ray. So we are explaining critical angle. So when light ray move from denser to rarer, denser medium to rarer medium, then the angle of incidence for which angle of incidence in the denser medium for which no, you can see the diagram, for which angle of refraction. Okay, that is very important. Angle of incidence in the denser medium, angle of refraction in the rarer medium, like glass to air, like glass to water, like diamond to air. Okay, this could be the case from denser to air, from kerosene to water. Angle of incidence in the denser medium for which the angle of refraction in rarer medium is 90 degree. Then what? Then that particular angle of incidence is called critical angle. You can see the diagram also. Then the particular angle of incidence is called critical angle. Okay, then that particular angle of incidence is called critical angle. So that is very important here. Critical angle is actually a particular angle of incidence. ठीक, when light rays move from denser to rarer. That is also very important. These two things are important. We are defining critical angle when light rays move from denser to rarer, and also it is angle of incidence. Now we can get a formula of critical angle also, and we can connect the relation critical angle with refractive index of denser medium. Okay, so I hope that you persons are enjoying this special discussion on refraction of light through critical angle. So now let us get a relation between critical angle and refractive index. Okay, critical angle and refractive index. Refractive index of denser medium. Okay, let's see. Here we are talking about maybe denser medium mu1, and this is rarer. We are getting refractive index mu2. Okay. Now we are using Snell's law. Okay, we know that Snell's law is very important, and for any refraction we have to use Snell's law of refraction. So we are going to use again the refraction which is taking place at xy surface. Refraction which is taking place at xy surface. Okay, so using Snell's law of refraction, for refraction at xy surface. Refraction at xy surface. Okay, refraction at xy surface we are talking. So see here what happens, what we can write. We know that sin I by sin R, sin I, and it is I3, and it corresponding will be R3. Now what is that? Refractive index of mu2 with relation to mu1. So we write mu2. Okay, refractive index of 2 with respect to 1. That we also write as mu2 by mu1. Okay. Now what is the sin I3? Now see here what we are going to do, what we are supposed to do. We are applying condition of refraction here. What is condition of refraction? R3, if angle R3 is 90 degree, then angle I3 is called critical angle C. Critical angle C. So we are applying this condition here. What we are going to get, see, sin C, in the place I3 we are writing C for critical, and in the place R3 we are writing 90 degree. Mu2 by mu1. Sine 90 degrees is 1. So sine C is mu 2 by mu 1. Okay. Sine C is mu 2 by mu 1. Now actually here we are defining refractive index of which medium? Rarer medium in comparison to denser medium. Actually refraction taking place here in rarer medium. Okay. Now then, what is mu1? Mu1 is of denser medium. Nothing that mu1 we are writing mu, and this rarer medium is air. Rarer medium is air. Okay. If rarer medium is air, then what will happen? If rarer medium is air, if rarer medium is air, then mu2 will be equal to 1 and mu1 maybe mu we are taking, refractive index of denser medium. Refractive index of denser medium. So what we see here, we are getting, okay, these two value we are putting here in this equation. 1. We are putting these two value. What we are getting? Sine C is equal to mu, actually mu2 is 1. So we have to write 1, and mu1 is mu we are writing. So what we see, that sine of the critical angle is reciprocal of refractive index, or mu is actually, why we understand this, you know, the refractive index of diamond is maximum. It is 2.25, and if you are talking about refractive index of diamond maximum, then critical angle will be minimum. So what will happen? If any light ray is incident more than this critical angle, then it will not refract, but it will go on reflection, and that is the condition of total internal reflection. That we will study in next video, total internal reflection of light, but that starts from critical angle. Okay, and refraction is converted to reflection. Refraction converted to reflection. Okay, when angle of incidence is more than critical angle. Okay, by diagram you can understand. Okay, see this is red color light ray whose angle of incidence is more than critical angle. This is critical angle, more than critical angle. Now this light ray will follow not refraction pattern. Okay, it will follow the rule of reflection of light, and it will bounce back in the same denser medium. and this phenomenon is called total internal reflection of light. On this total internal reflection phenomenon, we can explain many of the things happening around us, like mirage, looming, diamond, glittering of diamond, and what different thing we can explain. Okay, we will continue our discussion of total internal reflection in next video. Thank you, students, for watching this video.